Okay, so we should just get started. Um, Hello once more, and welcome to the Alternate School Disruptive Innovation Tech Program. At this moment, if your mic is still on, you can kindly unmute. And yeah, thank you very much. So, I am Sam Siraman, and I will be one of your trainers throughout this program. So, we are so excited to have you join us in this program. Along this journey, you will learn indispensable technical skills that are necessary to have in today's tech industry. Yeah, so let's get into it already. So throughout this call, we'll present you a lot of challenges and quizzes. Of course, the purpose of those challenges and quizzes is not to test you or see if you're smart enough. Rather, the point is to strengthen the new connections you are building in your brain. So I want to kindly remind you again at this moment, if you still have your mic on, kindly mute. Thank you very much. So again, don't worry if you don't get the right answer to a question the first time, because our research has shown that when you try to solve a problem, this effort by itself helps you learn. Sorry, I should just admit this person, and thank you. Oh, great. Yeah, so as I was saying, because research has shown that when you try to solve a problem, this effort by itself helps you learn better, even when you don't succeed at getting the answer. So by actively thinking about problem and trying to figure it out, you are priming your brain for a much better level of understanding. So yeah, joining our community. So of course, your alternate school disruptive innovation tech program community is one of the most powerful resources you will have at your fingertips during your learning journey. So, of course, we have already established some, tools we'll be using throughout, this program as a, we can literally call them the community tools. So, Twitter being the prime, and followed by Discord server. So I should hasten to say, WhatsApp will be snubbing WhatsApp. Yes, WhatsApp will still be there, will be connected and all, but WhatsApp will be for emergency. This really emergency cases. That you want to disseminate a quicker message. Or a way to trade you to one of our primary platform. So Twitter and the Discord server, of course, are our primary platform for these platforms for this program. So so within your online community, you can, using those two channels, or three maybe added to that, should be Google Classroom. You can be able to ask any technical question you have regarding your track content, or the field, of course, related to your track in general. So I should quick to know that also you can, at this point, if you have questions, if you are taking notes, for instance, you can send those questions, or indicate those questions in the comment below. All right, because this meeting is kind of tied to an hour 30 or so. So I'll be trying my best to keep this lecture, of course, curated within that particular time. But here, so as I was saying, you can be able to ask any technical question you have regarding your track content, or the field, of course, related to your track in general. So of course, you'll be able to get technical support from us, your trainers, and of course peers. Of course, we have emphasized that we'll be pairing you guys into groups on the Discord server. All right. So of course, again, joining our community, you'll be able to use resources and topics to deepen your knowledge in the world of technology. So such topics will be shared on the Discord server, or on our Twitter, official Twitter, account. All right. Plus, you'll be able to, of course, you'll be able to build your professional network. by being part of this vibrant, or a vibrant community of aspiring programmers. So sure, you know all the update and news regarding the Alternate School Disruptive Innovation Tech Program, and you'll be able to participate in interesting discussion about technology, careers, and much more with your team. So yeah, so in this lecture, you're going to get started knowing the fundamentals of web development, and you will learn some important concepts about how computer languages work along the way. So for your reference, here is the outline of this lesson. So we'll be discussing about website and web applications as one that provide visual and text content that the user can see and read, but not affect in any way. So in the case of a web application, the user can not only read the page content, but also manipulate the data on the page. So added to this, we'll also be discussing about the Hypertext Transfer Protocol, HTTP for short, which is an application layer protocol for transmitting a hypermedia document, so such as HTML, for instance. So the Hypertext Transfer Protocol was designed for communication between web browsers and web servers. But it can also be used for other purposes. So added to this concept, we'll be conferring about the progressive web app, PWA for short, the server-side development, client-side development, JSON, and Ajax, jQuery, etc., etc. So, what is really a web development? Okay, so of course, easy peasy. For sure, the web development, you can say, is it's about just creating website or applications that are meant to be viewed or used from within a web browser. Simple, full stop, easy peasy. All right, but the web browsers exist on just about every computing platform these days. So the most popular browsers are Internet Explorer for Microsoft, as well as its successor named Edge, Google's Chrome browser, and Mozilla's, of course, Firefox. Okay, so browsers, you should know, are designed to understand a standard set of technologies. Ideally, this means that developers can program to those standards and be confident that your applications will run anywhere for any user with a browser. So this isn't always the case, but it's certainly truer than it used to be. Building applications on top of the standards supported by web browser is so popular because it's easy to distribute those applications to anyone in the world with a computer, a browser, and a connection to the internet. So when you hear people talk about web development, you often hear them refer to website and web applications. So these two terms are often used interchangeably, but they do hint at some somewhat different types of web development that exist. So websites are generally just a tool for distributing information. Well, you can add these to the initial definition. So they are often just a collection of static web pages that present information about a specific topic. Okay. Plus, they will have links to the various pages. If you have interfaced, of course, you have interfaced. Even finding a way here, you must have interfaced with some series of website. All right, so we have links to the various pages on the site, and maybe links to other site on the intranet. But beyond the links on the site, there isn't much interactivity. Okay, an example of a static web page might be a blog you like to read, or a small local business site that just has a few maybe pages describing the services they offer. But of course, the goal of such a small local business site maybe is really just to convey static information. Right, so web applications are much more interactive. All right, they can be programmed to do a lot of different things, but they are particularly good at collecting data from users, storing it somewhere, and then presenting it again when needed. For example, let's take this example. Say, okay, So consider a hotel reservation application. It takes information, for instance, about the date of your stay and the type of room you like to store, you like, and stores it in a database somewhere. Okay, I'm assuming. So that data is then accessible to the hotel staff as well as to you if you return to the application later to confirm your reservation. So applications can also convey information like a website, but they usually provide a lot more interactivity and allow you to perform some set of tasks. Okay, so building a website or a web application really involves two distinct types of development. So there is the server-side development and the client-side development. I'll talk more about each of those later, but for now, I just want you to understand the general architecture. In almost all cases, an active network connection between the server and the client is required in order to use a web application. So typically, when a user clicks on a link or performs some other action in a web browser, a request is sent to a server somewhere on the internet. So the server will then execute some code or locate a request file and deliver, it to maybe over the internet back to the browser. So client-side code may then execute inside the browser to further process the data from the server. So without an active connection to the internet, none of this communication is possible. All right, so I mentioned earlier that web development is performed against a set of standards that are supported by all browsers or all web browsers. So that also implies to the network connection between browsers and servers. So they communicate using a network protocol, as we have already explored, known as HTTP. Yes, you guessed right, the Hypertext Transfer Protocol. Okay, so the HTTP protocol can also be encrypted, all right, and is then referred to as HTTPS, all right. So the S being short for secure. You have undoubtedly seen HTTP and HTTPS as the start of a website address. Like I said, maybe juggling here, you must have, come across one way or another, several kind of website, most notably HTTPS. So it's really there, okay, as an instruction to the browser. So it tells here, okay, it tells the browser, okay, to use the HTTP protocol to communicate with a specific website. Most browsers support a handful of other protocols, but HTTP and HTTPS are far and away the most, of course, commonly used. Great. So the PWA. Not all web development is done with a desktop web browser in mind. Okay, of course, that's just by default. So since the earliest days of modern smart people and smartphone and people, there have been attempts to make web applications and and perform like the native mobile applications. So the techniques used to do this have evolved over the years, but the current best practices have been collected into a set of techniques. Sorry, I should just. Oh, great. I'm just following the WhatsApp group to. Oh, okay. All right. So such techniques used to do this have evolved, of course, as I was saying, over the years. But the current best practices have been collected into a set of techniques to deliver what is known as a progressive web app, or a PWA for short. So these PWA use some advanced imaging and web development techniques to give users an experience similar to the native apps they have become accustomed to. So PWAs load faster than the typical web application. Okay, they can also be installed on a phone like a native app, and often have other features not typically associated with traditional web apps, like storing data on the client and receiving push notifications. So they are certainly worth considering if you're interested in leveraging your existing web development teams to also deliver a nice mobile experience for your user. There's a time for that, but when we get started with the real coding, when we get started with getting our hands dirty, then of course. So next, I will talk about the skills required on a typical web development team. Hope you are still there, and stay tuned. Great. So in this module, I will go over the skills required on a typical web development team and how, of course, they may or may not neatly map to any given group of developers. So let's start by talking about client-side developers. So these are the people that write the code that we execute inside the user's web browser. The browser presents the user interface of an application. So good client-server developers often have user interface and user experience design skill. So these are often abbreviated UI UX, and people with those skills are often referred to as UI UX developers. You may have, of course, heard about those. So these set of people, or people with such set of skill, use hypertext markup language (HTML) to lay out the structure of a web page, and cascading style sheet for short, CSS, to apply visual styling to those pages. So I will talk about more. I will talk more about HTML and CSS later in this lecture. So, but you should know the client-side developers are also usually very familiar with the JavaScript programming language. So JavaScript is a full-featured programming language that is supported by all of the major web browsers. The popularity and capability of JavaScript has exploded in recent years, which means that many modern web applications have as much or more client-side code as do server-side code. So that was not the case in the early days of web development, you should know. Client-side development has even grown to the point that it's not uncommon for there to be some specialization on larger teams, okay? There may be developers that focus more on HTML, CSS, and user experience, and others that focus more on writing JavaScript. However, you can't build a web application with a team full of client-side developers. You of course, also need some server-side developers. That's where we will go next. All right, so server-side developers, as opposed to client-side developers, as you probably guessed, focus on writing the code that execute on the server. So the skills required to be a server-side developer are much less specific than those for client-side developers, since server-side developers aren't bound by the specific technology supported by the web browser. There's more flexibility when choosing a programming language and application development framework, but it's still necessary for server-side developers to be proficient in at least one of them. I'll talk more about some of those options that exist later in this lecture also. Okay. Server-side developers generally spend less time worrying about the user interface and more time gathering, processing, and delivering the data and resources needed on the client. So this often includes things like gathering data from an internal company database, making calls to third-party services, or just implementing proprietary business rules and calculations before sending the result down to the client. So because of these, it's often important for server-side developers to have experience with relational databases and integrating with a disparate system. It's true that just about every web application require both server and client-side development skills, but it's increasingly the case that members of many teams have skills that span those required for the server and client. I'll of course talk about that development trend next, which is full stack developers. So over the years, the lines have blurred between the skills required for client and server-side development. The rise of JavaScript has many client-side developers processing more data and doing less, design work. The same need for data processing on the clients has led to more server-side developers working on the clients and picking up some UI UX skills along the way. So these has all given rise to what is now known as full stack development. So a typical web development stack might include HTML, CSS, and JavaScript development on the client, a different programming language on the server, and likely some database-specific code to interact with and an underlying database management system. So a full stack developer, as you may already figure out, is someone that's proficient at working in all of those areas. Okay, so these are some obvious benefits. As a full stack developer, you'll be familiar with the whole stack, and developers familiar with such stack, don't have to wait on the client side developer to come back from a vacation, for instance, to troubleshoot a JavaScript bug. So they also generally have a more holistic view of the application, and this can lead to a better system design decisions. But of course, one potential drawback to filling the team with full stack, having a team of all full stack, developers though, is that it's difficult to maintain a deep knowledge of all of the technology used in the typical web stack. Rarely, those a kind of generalist have the deep knowledge of a specialist. I don't know, say that. That's just a code. You can Google that. Yeah. So yeah. In addition to client-side developers, server-side developers, and maybe the occasional full-stack developer, I intentionally said occasional because every developer is trying to attain this stack because of its limited and occasional benefits to say. So there are a few additional skills, of course. Sorry. Excuse me. So there are a few additional skills that will likely be required to successfully develop and deploy production. Okay, so these include system administration, maybe database administration and network administration. These are additional skills for developers to pick up at least. So the specific tasks performed might include configuring and securing the servers that host the web app, creating and turning the database, and configuring firewalls and routers to allow all of the appropriate network traffic through. These are additional skills that may be required, as I rightly call it, but these are optional, of course, not mandatory. Okay, you can have these just as kind of a backup skill. I don't have maybe more of these, not all of these really, not all of the additional skills I'm really listing here, but because in large organizations there may be separate people that specialize in each of these things. That's why I don't have all of these additional skills. So in very small organization though, okay, the developers may have to pitch in to handle them. That's why you should have these additional skills, and that's why they may be required. All right, so these are generally peripheral tasks when you think about the development of a medium to large web application, but that does not mean they are not important. So it's always better to know ahead of time that you will need those skills and have people with them ready to help when it's time to deploy that shiny new application. Okay. So I mentioned earlier that one of the reasons for the popularity of web development is that developers can code, to the standards supported by web, browsers, and trust that your code will run on any computer in the world that has a browser. So this is true, but the reality is not quite so idyllic. The reality is that, okay, all of the browser makers aim to support web standards, but they are very competitive and are always working to make your browser faster and more user-friendly. Okay, the result is that there are occasionally small bits of code that work perfectly well in one browser and either generate an error or maybe just look a little different when you rendered one of those in another browser. Okay, the browser renders the user interface of a web application, so even slight differences in how a particular browser displays a button or position to user input from can be very noticeable and distracting too. So the likelihood of running into one of these compatibility issues is not near as great as it was several years ago, but it's still something developers need to consider. You need to consider that as a developer, unless you know that you are developing an internal corporate application, you um, and you know that all of your users will be using a particular browser, then part of web development really needs to be testing your application on multiple browsers, so you can be sure all users will have the experience you, of course, expect. Great. So HTML and CSS are the two technologies that most directly control the visual appearance of a web application. Okay, that that you should know by now. Okay, but of course, HTML stands for hypertext markup language, and it's used to define the structure of a web page. So developers use HTML to do things like add a new paragraph of text to a page, add the input boxes for a data entry form, or include a button the user can click to have your data saved to the server. Uh, there are a few pieces of HTML specification that lets developers control the visual appearance of the elements being added to a page. But for the most part, HTML is about defining what goes on a web page. Full stop. Okay, how those elements appear on a page is really the domain of cascading style sheet, more commonly known as, yeah, you guessed right, CSS. But CSS allows developers to apply, styling to the page element they define in the HTML. That styling could include things like particular fonts or text formatting. So the colors used on a page, or how HTML elements are positioned relative to one another. It's important that developers define the HTML of a page separately from the CSS. Well, that's a convention we get into when we start getting our study on, the actual coding. But it's often helpful to users to adjust the visual appearance of a page depending on the type of device a user is using. There's a word for that. Yeah, media queries, of course, but we should get to that when we start exploring, the nitty gritty of CSS. So if they are using a desktop computer with a large monitor, then an application might detect that and load a CSS file that formats HTML with lots of menus and navigation items that might not fit well on a smaller display. Excuse me. So if the application detects that user is using the web browser on your phone, then a different file might be applied that hides some of the menus and reformats the content into a form that's easily scrollable on a small screen. So it's the same HTML code, but the CSS is used to detect and present it in the best format for the device being used. So all of these, all of such lengthy explanation, all envelopes into a key concept, like I mentioned earlier, media queries. But like I said, we explore that when we start getting our hands dirty with, the CSS nitty-gritties. Great. So HTML and CSS are great at structuring and presenting web pages, but adding lots of interactive functionality requires a full-featured programming language. In web browsers, that language is JavaScript. So the official name for JavaScript is ECMAScript. I don't know first name that, but that was such a lame name. Thankfully, we can call it JavaScript. So of course, I don't know if you already know this, but you should know that JavaScript is not Java. Well, I started that way. I started in my understanding of JavaScript, really, pioneer that way. I thought JavaScript was just, the mini, Java. But there, of course, it's a whole standalone programming language. So, however, I think the ECMAScript was named after the organization that standardizes the language. You should Google that. But however, JavaScript is the name you will hear most often, thankfully. Yeah, the earliest versions of JavaScript were really just used to add small bits of flair to, web pages. But over the years, the language evolved and developers started doing more and more with it as it is now. So it's now not uncommon for web application to include as much client-side JavaScript code as it does server-side code. So writing JavaScript code instead of server-side code has a couple of particular advantages. I beg your pardon. So first, it reduces the processing load on the servers. Okay, so code that uses to execute and take up CPU time on the server can now execute in the user's browser. Second, because the code is executing in the browser, it improves the, of course, overall user experience because the application will generally be more responsive to the actions taken by the user. And when data needs to be sent to and from the server, JavaScript can use a special data format known as JavaScript Object Notation, or JSON for short. It's a very human readable text description of data that JavaScript can easily process. Oh, great. Ajax. So, a little history. So, until the mid 2000s, if the user of a web application took some action that required a partial update to a web page or required that some data be retrieved from the server, it usually meant that a request had to be sent to the server, and an entirely new web page had to be sent back, down to the browser. So this was true even if it was only a very small portion of the page that was different from the original. But eventually, a set of technologies collectively known as Ajax was added to JavaScript and supported by browsers. So Ajax stands for, yeah, you guessed that on the screen, asynchronous JavaScript and XML. So let's break those terms down so you can understand how these fundamentally change client-side web development. So Ajax, sorry, I think I need some water. It's far away from me. Anyway, let's just continue. So Ajax requests a network request made to the server asynchronously, which means that they are really made in the background so that they don't disturb or delay the other processing that may be happening in the user interface inside the browser. So the alternative is to make requests synchronously. Okay, I'm really careful using asynchronously and synchronously. You should know. So the problem with synchronous requests is that nothing else can happen in the browser while it waits for the request to go to the server. So perform some process and then return to the client. Of course, there's no concurrency happening here. So this appears to the user as if the application or your browser is frozen or locked up. I'm sure you have seen applications that exhibit this behavior, and you know how frustrating it can be to use them. I have. I don't know if you have. So by performing tasks asynchronously in the background, the user interface can remain responsive and continue to update based on the user actions while it waits on the response from the server. So I mentioned that Ajax stands for asynchronous JavaScript and XML. So the XML part refers to a data exchange format that has largely been replaced with JSON in modern web applications. With the ability to make requests to the server asynchronously, there was suddenly lots of potential for building web applications that operated much more efficiently and only updated portions of a page at a time. So that ultimately led to the development of modern client-side application frameworks, which I will talk about next. So as the capabilities of JavaScript grew and more developers started to take advantage of Ajax requests, it became possible to build many more application features in client-side apps than ever before. Client applications began to resemble server applications in terms of complexity and the quality of code being written. So that level of complexity led to a need for large application building blocks that already had in place some of the most common bits of code that many applications needed, and that would speed the development of individual features. So the first really popular tool that began to fill that need was a library named jQuery. So among other things, it includes a lot of built-in functions that make it easy for developers to make Ajax requests and then update particular pieces of pages with the result that come back from the server. I refer to jQuery as it may be usually referred to jQuery as a library, since it's really a collection of helpful functions developers can use, or easily use, with just about any client-side app they need to build. So the huge success of jQuery eventually led to the development of what I would call client-side application frameworks. Because rather than just being a collection of utility functions, frameworks provide much of the scaffolding needed for uh, a medium, um, of course, to large side modern a browser application. Scaffolding there means support, just so you know. So some of the most popular frameworks are Angular, which was developed by Google, React, which was developed by Facebook, and Vue, which was originally developed by a former Google employee and Angular user. Okay, so these frameworks let developers build what has become known as SPA or SPA. So SPA stands for, yeah, you guessed that right, single, page application. So not all SPAs are literally a single page, but the general idea is that the client-side app can load a single page, and then all of the functionality inside the app consists of small, partial update of that page. Client-side frameworks enable this type of application by making heavy use of AJAX requests. So the result is often a very fast and responsive application that feels like, maybe less like a traditional web app and more like a native application. Each of the frameworks I mentioned has a bit of a learning curve, you should know. But once developers become familiar with one of them, of course, they can usually get big featured application off the ground much quicker than if they had to code everything from scratch. I mean, who does that nowadays? Yeah, nobody, start coding from scratch, unless otherwise. But yeah, so despite the huge growth in popularity of client-side development in recent years, server-side development is still a very important part of just about every web application. So there are, really three main roles the server plays in the typical web app. The first is that it runs some web server application, and this really just means it's running an application that can listen for and respond to requests made with the HTTP protocol I discussed earlier in the lecture. The second job of the server is to deliver to the client all of the HTML, CSS, and JavaScript needed to run, the browser application. In some, but certainly not all cases, that client-side content will reside in files on the server. So, but when a user visits an app with your browser, the server delivers those files so the user interface can immediately be shown and the app starts receiving input. The server may deliver other client-side content over time, but there is usually a minimum set of content that must be sent to initially get the app running in the browser. Of course, the third job performed by the server is to execute custom code specific to a particular application. This is the largest of the three jobs the server normally performs and can obviously take many different forms. Some common tasks to perform on the server include saving and retrieving data to and from a relational database, retrieving data from other internal corporate applications like HR and financial systems, and connecting the third-party applications to services that contain other information needed by your app. In addition to gathering and delivering data to the client, it's also common for the server-side code to implement business rules that apply to your application. It can be beneficial to implement business rules on the server in case you decide to use, the same server code for multiple client applications. So they can then take advantage of, one implementation of, some kind of business rules, yeah, or so. So what are these programming languages and frameworks really? Because unlike the client-side developers, server-side developers aren't limited to using the technology supported by web browsers. I mentioned that earlier. Okay, server-side programming languages and frameworks need to be able to communicate over HTTP and ideally, be able to send and receive JSON data. Okay, and there are a lot of languages that can be that can do those things, in addition to the programming language itself. So the best options also include a framework that already has much of the infrastructure in place for communicating with the client over HTTP. One popular choice is Microsoft's ASP.NET Framework. It's built on top of your popular .NET application development framework and works with several programming languages, including C# and VB.NET. So Java is another popular choice. It's a full-featured general-purpose programming language, and there are a lot of web frameworks you can choose to use with it in recent years. Uh, Node.js, pardon me, .js has also become a popular tool for building server-side application. Node applications are written in JavaScript, so it has the advantage of letting your team use a single programming language on the client and server. So I should hasten to mention Python and PHP. Of course, they are also popular server-side programming languages, but don't assume that your only choices are those I've mentioned here. There are a lot of other options, and choosing a server-side language and framework can have as much to do with the existing skills and experience on your team as it does with the technical features offered by the different tools. So server-side code obviously requires a server, and that comes with its own set of choices when deciding how to architect, your web applications. Windows and Linux are easily the two most popular web operating system. Okay, so but keep in mind that Linux comes in several popular distributions from a variety of organizations. Which server operating system you choose will probably depend on the existing skills and experience on your team, as well as the technical standards that may already be in place at your company. So in addition to choosing an operating system, you must also choose where to host your application. If you work in a large organization, you may already have in place a data center with the infrastructure necessary to support and maintain your application. However, it becomes increasingly popular for organizations of all sizes to host web applications with one of the large cloud providers. Microsoft Azure, Google Cloud, and Amazon Web Services are all popular cloud hosting providers. So there's a common joke that, of course, you might have heard of this. The cloud is just a fancy name for someone else's computer. That may be good for laugh, but if you assume that oversimplification bears any resemblance to modern cloud architecture, well, that's true. Just to note, but then you are likely, going to miss out on some significant benefits offered by these services. So, cloud architecture can easily be the topic for an entire course, and there are a lot of benefits to hosting with a cloud provider. But the one I will mention here is that you can usually very easily scale out an application to multiple servers in the cloud. So this can be handy if you suddenly have a spike in traffic, or if there are certain times of the day or week when you need more capacity. So implementing something like that on your servers often requires a lot more effort and I think expense. Yeah. Here we are. We are at the end of the tunnel. Well, the first tunnel of several tunnels. Yeah, but there's light for my end. So here are my final thoughts. So I think web development these days involves more technologies and a greater variety of skills than ever before. But however, it's also more possible to deliver fast, beautiful apps and more capabilities than ever before. So I hope this lecture was has given you a better understanding of how to build modern web applications. We'll dive, we'll kind of have this deeper conversation and dive deeper on all of the topics I've covered. Practically, you get your hands dirty. You see how it really works, how the media queries go around, how this team architecture and the cloud services and all. So yeah, I hope you keep learning. So thanks for listening, and good luck on your next class. We hope you enjoy this uh, lecture. So I would recommend that maybe I was fast. So I would recommend that um, you wait, go over. We are looking forward to recording this live. So we'll be sharing this live with you. You try to immerse yourself in the concept shared here today, and then you can. But if you have a questions right now, but that's just my recommendation. Try to immerse yourself during the day. Look at it properly. Note the concept. Because you'll be updating your learning journey. I think we should have that as a lecture, as a whole lecture. You should be updating your learning journey on Twitter. So day one, blah blah blah, and you should always tag us. Reach out to the if you have not followed us on Twitter, you should already. You should. I mean, why are you not following us already? You should, because that's where everything is happening. And look for our handle. Tag us on every post you making on Twitter. Well, technological post, want techie stuff. Just tag the alternate school. And yeah, so starting today, after you immerse yourself in the video, I hope this was recorded properly, because we'll be sharing that. You watch the video, and note your concept, the concept that you learned, and share it with the world, and let them know there's someone who is getting started with coding already. So again, thanks for listening, and I hope you've found this useful. So any question from your end? Anyone here with questions? Yeah. Okay, so I assume you guys want to go with the recommendation. So immerse yourself on the live video. Will be sharing the recorded version. So you can have your questions later. And okay, Julian is there. Yeah, Julian.
Yes, this is aside from what you planned. When is the next class?
Oh, great.
We will be having classes during
Yeah. So I yeah, you guys didn't maybe because we shared the curriculum, all of that was listed. So the next class should hold on Thursday. That's a Wednesday, 12 a.m. to say.
Okay, Wednesday nights.
Yeah, Wednesday night, correct. So it's 3 times a week. So that's Tuesdays,
So that's Tuesdays, Thursdays,
and Saturday. So I think Sundays will be for a live project, live, yeah.
so Friday night.
Yes, Friday night, correct.
Thank you.
All right. So otherwise, thank you guys, and see you on Twitter. I'll be looking out for your update, for your learning journey update. Okay. So if you find any difficulty on tweeting, but we should have that as a lecture. I believe we have that. Committing your learning journey or so. I don't think what I can't remember what it's called, but we have kind of that. So yeah. All right. So thank you, Julian, for being here. So in 1 minute, I'll be ending this live. So if there are any other, if you guys want to say something else, yeah. That's really cute of you to say. So yeah, you're so you should also say this on Twitter. You should, because Twitter, that's where everything is happening. You should let Twitter know that you enjoy this cause, and there's something like this going on. So what I will do, I think I'll just make the lecture after here on committing your code on Twitter. I think I should just do that. Let's see how it goes. I will try to have the recording and try to share it. Yeah, ASAP, because you committing your learning journey should go hand in glove with this. So yeah, I think before day breaks, yeah, you should have that. Great, welcome. So, anything from the other guys in less than 30 seconds? I'll be ending this live.
Well, my question is, how long will this course last for?
Uh, okay, so great question, Alfred. Although off context, but all of these questions were answered on the curriculum we shared. So the curriculum is on the Google Classroom. So if you're not on the Google Classroom already, there is a link appended on the WhatsApp description. It's there, Google Classroom. You should access that, and yeah, but it's 36 kind of weeks, because we are trying to do the front end, bring in back end, and make you guys full stack. But at least after 6 months or so, is it 6 months? I'm not sure, but after, you should go back to the curriculum. Maybe guys might want to hop out after being a front end developer. That's fine. But we are here to take you guys to the back end development and all of that. So yeah, it's a long haul, a really long haul, to becoming this agile, web developer, because we're trying to break the concept for you, the industry standard, trying to have you attain the industry standard and all. Yeah, thank you. Great. So in 5, 4, 3, 2, 1. Thank you, guys. See you in the next class. So we'll try to make the video available to you guys, and hope you find this again useful. And thank you. Good night.